So far is that it's been getting very, very noisy in the theatre, which I have been trying to combat. But if you feel the need to have a chat, which sometimes I know is just irresistible, please feel free to step out of the theatre, have your chat, and then come back, because it's too loud for all the other students in here that are actually trying to listen and to learn. So it's not fair to their learning. So if we can just keep a nice level of noise, that would be lovely. All right, so today, week 9, I bet you're all exhausted. The weather's not that nice either, so even the skies are crying out for a break. Only one more week to go. This is also going to be the last day that we're going to learn something new. Next week is going to be all about revision. So everything that we do next week is not going to be new material, which will give you a little bit of space to breathe and to actually, catch up a little bit as well. And hopefully also focus a little bit more on your assignment, because the assignment will be due at the end of next week. Okay, so today we're going to talk about the exam, and then we're going to do that whole new thing, which basically involves using multi-file projects and doing some multi-file stuff, which is a really nice place to kind of finish off on. And what I'll do as well at the end of the lecture is I'll run a poll so that I can poll you based on what topics you would like to do next week as revision. And I will go over those topics again, and we're going to do lots of problems around those topics as well. So we're going to solve those problems, and then you're going to have similar problems to practice with as well. Okay. All right, so, okay, oh yes, my experience surveys. They are out. So now for the next 2 weeks, yeah, Ben's doing a big yay. For the next 2 weeks, you'll just get lots and lots of reminders to please fill out the My Experience surveys. For those of you that don't know, these are the surveys that are sent out to all the students for each one of your courses. And basically the feedback that is gathered in this survey, we use it to improve the course for the next run of it, and we use it to really kind of improve our teaching as well. So please, when you have a chance, fill out the My Experience surveys. You will also get a chance in next week's lab to do so, and help us make the course better as well. Okay, the exam. This is the exciting stuff. I bet everyone's excited about doing an exam. So what's going to be in the exam? Oh, thank you. Everything that you've learned so far, nothing is off limits. Lots of focus on, looping, variables, strings, arrays, pointers, linked lists, literally everything that we have done in this course so far. So everything is in it. The exam, yeah.
Is the multi-file stuff that we're going to do in the community exam?
That is a very good question. I will answer it like this. You will not need to know how to make a multi-file in your exam, but if you reach the end of the exam, perhaps it might be useful to know what on earth a multi-file is. And I will say it now, and I'll say it later again, not all of you will reach the end of the exam, and that's perfectly okay. And we will talk about that as well. Okay, so the exam is going to be on the 2nd and 3rd of May. That is not what your formal timetable says. I believe it says the 2nd and the 5th of May. The exam is actually the 2nd and the 3rd of May. Please do not contact the exams unit. They dislike us enough as it is. The reason for that is that some of you have a maths exam as well. And for those of you that have that maths exam, maths did not put into your formal timetable that they are running 16 sessions that you can choose from. So we felt the need to change our exam so it doesn't clash with your maths exam. And by the time we changed it and realized there's 16 sessions of your maths exam, it was too late to change it back. So for those of you that have a maths exam and it is on a day that the comp exam is on, next week you will receive an email where you have to preference a time to sit the computing exam. please, please, please make sure that you preference a time that doesn't clash with your maths exam. Because if you do not preference a time, we will automatically allocate you to a time. And if that time means that you're sitting a maths and a comp exam in that day, that's bad luck. So please, please, please preference it so that you can be nice to yourself and not have potentially 2 of your hard exams on the same day, which would not be that pleasant. So we've got 4 sessions on the second morning, afternoon, and on the third morning and afternoon. Our morning session is 10:15 to 1:30, and our afternoon session is 1:55 to 5:10. What we do in the middle is called corralling, okay? And what it means is those people that are sitting the afternoon exam have to come early at 1:20, okay? And at 1:20, we hoard you all into 1 or 2 or 3 rooms, and we keep you there for 30 minutes whilst the changeover happens. And that means that you don't have time to discuss what's going on with the morning people, basically. So if you arrive at 1:30, you will not be able to get into the exam because the doors close at 1:30. Please, please, please be on time. It's really important to do so. The exam is going to be all over CSE, okay? It's going to be in every possible lab. When you will be given a seating arrangement closer to the date of the exam, so you will know where to go. So don't worry about that. That will be given to you. You will have a seat that will be kind of, that's your seat. That's the lab that you're sitting your exam in. Okay, so that's the exam and the time of the exam. Is that okay with everyone? Everyone understands what's happening there? Yep, okay. Good, okay. Now, next week you will have a lab, and obviously you'll have a lab every week, but next week's lab is going to have a practice exam. Okay, that practice exam is going to be sitting inside the same environment as your exam, which means that we get to check whether or not everything is okay and you're able to log in and everything is hopefully going to work during your exam. Now, sometimes things go wrong during your actual exam. It has happened. We have had a server go on fire. We've had evacuations. We have had the whole system shut down. So sometimes things do go wrong. A bit of fun, maybe not so much for you or for me, but for others that are watching this, complete chaos. But hopefully this time things will go smoothly, we hope. So this exam environment basically means that we'll be able to check that everything hopefully will go smoothly and we can take one variable out of the equations. So it's going to be similar to what you've been doing so far. There is nothing really that's that much different. The only thing that's different about this exam environment is that, no, I haven't said it there, but I'll say it in a few more slides, is that it's going to close down everything. You know, you won't be able to access a lot of things, and I'll talk about that in a second. Okay, in the exam, there is going to be an array hurdle, okay? So what that means is that you must get 50% or above in that question, either question 5 or question 7, to pass the exam. It's a hurdle. And there's a linked list hurdle as well, and there's going to be a question 6 or an 8, and you must pass that question, one of those questions, to pass the whole course, basically. And those questions that are hurdles will be clearly marked on the exam, so you're not going to be left wondering what is it that I have to pass to get through this course. Okay, so the exam is closed book. Okay, what that means is that exam environment is not going to let you access anything outside of our course website. Will be open to you. That means you will have access to all of the lab exercises and solutions, and also to the lecture code and the lecture notes. So that will remain available to you. Yeah.
Are we able to access that on our own account? On the VNC account that we connect to, our previous tutor or laptop?
No. So you'll go, you will have the course website, and that's
it. and then, yeah, everything else is locked down. So, yeah. Yeah. Okay, so exam, yeah.
Do not communicate. Is that before or after? 24 hours before the exam start time?
24 hours after the exam time. Do not speak after you sit the exam. Do not discuss the exam for 24 hours afterwards with anyone. I mean, you can say I found it to be a horrible exam. I found it to be the best exam I've ever done. I think I've done great. What that means is do not discuss the questions that were in the exam. Okay? Now, there is two exams. Okay? You're not, those people that are sitting an exam on the second are not the people on the third. It's not exactly the same exam because that would be madness. It is two different exams, so it's not, you know, having your friend sit it on the second that might tell you something for the third is not really going to help you at all. It's going to be a different exam. The papers are personalised as well, so the person next to you might be getting something else. Okay, so exam conditions applied, which means you cannot discuss it and you can't share your code. You know, be mindful of what's going on, and yeah, just don't do it. Don't communicate about the exam. Okay, if you have any issues during the exam, please raise your hand and we will come and help you. We are all around, and you will have invigilators. They will call me. I'm on call as well, and you'll see me around all the labs moving around. Yeah. No, see, you don't see your own stuff. You only see our stuff. Yeah. Okay, so if any issues at all, and that means if you're feeling unwell, if you think that there is a mistake in your exam paper and you don't know what on earth it's asking you, raise your hand, let us know, okay? Because that has happened before. Or if something is not working, if something is failing, this is... God, it's gone down so much. Hey? What's that?
Nothing will catch on fire, but
don't make promises we can't keep. Things might catch on fire. It's happened before. It's happened twice to me, in fact. Twice. There's been 2 fires in the times that I have ran in-person exams. Last term, everything went really great, kind of, except the air conditioning wasn't working in the lab. As usual. So, and we actually, a few people were quite unwell, so I was out at the shops getting waters. Exams are super fun. We're not going to have that problem because the weather's cooled down, and also I've put in 3 notifications that we're running exams to please switch on air conditioning. Okay, so when you come into the room, you'll seat yourself. What will happen then is you will, you know, get ready for the exam. It will be super exciting. You'll have 10 minutes to read the exam, so you can't code in the first 10 minutes, just reading time. It's your relaxing time. It's just, you know, reading through it, thinking through it. Sometimes when you read through the exam, you're like, I don't know why I'm here. I don't want to be here. Please don't feel dejected, because when you start doing it, things often get better. We do have people test the exam to make sure that it's not too hard, but not too easy either. So hopefully that will be, hopefully it will all be okay. All right, the university has a fit to sit policy. What this means is that if you come to the exam, you have declared yourself fit to sit that exam, and it is very difficult to apply for special consideration after that. If you wake up on the morning of the exam and you're not feeling well, please do not come to the exam. Go to the doctor. Okay? Last term, we had someone with COVID show up to the exam, and halfway through they became very unwell, raised their hand, gave us all COVID, and then they had to leave the exam. Not fun. If you do not feel well, please don't come to the exam. You will get to sit the supplementary exam. Okay? We will not, you know, we will do you a solid. You'll still get an exam. Don't worry. But it's really important that you go see a doctor and apply for special consideration after that, okay? Okay, Now, it does happen that you feel okay, then you show up to the exam and suddenly halfway through you do not feel okay. That can happen. If you start feeling unwell at any point of the exam, please stop working on the exam immediately. Okay, raise your hand and call an invigilator over. They will mark down the time and they will note down that you're not feeling well. Head to the doctor and get them to issue a medical certificate for you, okay? And then you need to submit a special consideration. So what you can do is you can submit the special consideration and attach a medical certificate within 24 hours. It's really important. If you're feeling unwell to start with, don't show up. And if you're feeling unwell during the exam, please stop doing the exam. Don't push yourself beyond the limits, okay? We've had students that have felt very unwell, which has resulted in having to call ambulances as well. Please, I don't really want to have anyone feel unwell, and I don't really want to spend my evening, sitting with you waiting for an ambulance. Please just don't relax at home and then sit the supplementary exam. Okay, if you are granted special consideration, which frankly, if you are feeling unwell, you will be, right? We're not, they are given for medical if you're not feeling well medically. You will be granted a supplementary exam. That exam is going to be held in May this year. I can't remember the exact dates. Ben, can you just quickly look up when the supplementary exam is? There is a block of time. There is, just Google, there's a block of time that's allocated to it. Now, if you are given a sup exam, you have to be available for it. That means you can't be away on holidays. You will not be given a second supplementary if you're away on holidays. It can be that you are still feeling unwell or something is not right. That does happen. You'll need to apply for special consideration again if that's the case. Okay. Now, in week 11, we will be running some revision classes, and you will be welcome to register for them. I will provide details in my announcement next week, end of this week. So you'll be able to register, whenever you want for those classes. There's going to be quite a few classes running, so hopefully you'll be able to get in. And if those classes fill up, we can put another class on, kind of thing. So it's based on demand. Okay, now CSE SOC is also running their own, I don't think they even call it a prep and chill anymore, but I still do, because I think that was a great name. They are running their own exam prep session. It's going to be this Friday. No, it's not, that was last time, 3 till 6 p.m. this Friday in J17. I think they're putting on some food and some problems as well. They were talking about doing a mini lecture, so if you have not been all talked out and talked to, then you can go along, sit through the mini lecture, and then do the problem sets that they have. They have prepared some problem sets for students as well. Okay, so that's the CSE SOC exam prep as well. Okay, in week 10, okay, what are we going to be doing? We will be flipping the classroom, not quite, but we'll be kind of flipping it. So what I'll do is when you vote at the end of this lecture, I will put together what topics to revise, and what we're doing is putting together questions. So what will happen is we will do a question together, we'll go through the topic, do the question together. Then you will have a similar question that you can do whilst a few of us will mill around the room and help you out if you have a problem as well. So that's kind of what we're going to do there. It would be really cool to know how many people will show up next week, because then I can book a better place than this theatre. Okay? A poll. Oh, amazing. We could do that, because this room is not my favourite. Okay, so that's both on Monday and Thursday, which is super exciting. All right, let's talk about the format of the exam. Everyone always wants to know what's the exam going to look like. The exam will have 11 questions in it. And they are going to be question 1 to 4 is going to be 5 marks each. These kinds of questions will require you to understand the code and what is potentially wrong with it. Maybe some diagrams will have to be interpreted, perhaps. Those are the, I don't know, you can do them to start with, you don't have to do them to start with. It's up to you how you approach the exam. I do recommend that from question 5 onwards you go in order. Okay, question 5 to question 8 are 12 marks each. So there's 4 questions, they're 12 marks each. They are programming questions, okay? So, and these are your hurdle situation questions. What that means is question 5 or question 7 are array hurdles, question 6 or question 8 are linked list hurdles. So if you have done question 5 and 6 and you've passed them, you've passed the hurdle, right? The rest of the questions are now for marks only. Okay, question 9 and 10 are going to be more programming questions, and question 11, 10 marks, is going to be the piece de resistance. Very few people get to this question, very few people attempt it, but I do love watching the people that do, and I really love reading the pseudocode of those that do and the comments that they make in them. Sophia, you left me a beautiful comment in your exam. I really appreciated that. It makes marking a lot more fun. So, these kinds of questions will be similar in style to what you have been doing so far in your labs. There are no surprises in this exam. I mean, except for the actual questions that you're getting. But there's no surprises in terms of the structure and format and the way you give and so on and so forth. So what that means, also the questions are rated exactly the same as your labs. You will know exactly what questions you perhaps should be attempting and should be getting, and what questions might be a little bit too hard, and you can just call it a day. So if you have spent the whole term not being able to do any 3-dot questions, it is highly unlikely you'll be able to do it in the exam. You can, of course, attempt it, but you can attempt it based on the fact that you know, you're just attempting it for a few extra marks, so you don't have to feel, bad. So I hope that everyone will attempt and complete the first 8 questions. That means all of the 5-mark questions and all of the 12-mark questions. Anything after that is bonuses, I would imagine. Okay, questions 1 to 4. They're your little 1-dot questions, and they're worth 5 marks each for a total of 20 marks. These questions are all about whether you understand coding concepts, the C programming language. You have to maybe be able to read some code and say, what will this code do? What values does it take? How does this code work? And you might have to debug some code. We will have examples in the week 10 practical exam. So you will have a practice exam, and you're going to have some indication of what that question is going to be like. Yeah?
Will those require us to type out our response?
It will potentially require you to fix errors in code and then make it work or make it produce desired output. Yeah?
Will we be able to compile the code into
You will be able to compile the code. We are not stopping the compilers. That might be unhelpful. Yeah?
Is it like, when you do the test, is it on like a locked
It's on a locked, yeah, it's on a locked, the exam system's similar to everything else, but it's a locked system, so you won't have access to anything outside. All right. Okay. Now, questions 5 to question 11, they are similar to the revision exercises and the problem sets. And stages of difficulty will go from basic, so from 1 dot to very hard. The very hard questions is like, the last question is a mixture of the 3 dot and the skull question. So it's meant to be there to really challenge you at the end if you got to the end. And that's why it's worth 10 marks. So not that many people attempt it, and that's okay as well. Okay. So some of the questions, some of these programming questions will have some starter code for you. And what I'll do next week is I will show you what that starter code looks like, and what I will also show you is how to test your answers. If you wanted to test them yourself without auto test, how to do that by using, our code that's included at the bottom, because it will allow you to actually run your own testing on it. Yeah.
Are the questions like
is a very good question. You can get part marks. And to make you feel better, even though the exam is auto-marked, all of your hurdle questions we will look at manually as well. We want to give you as many marks as possible, and we want to make sure that you're able to get through the exam. So, yep. So you will have access to auto tests, but remember that auto tests are just that, they're auto tests. We might not be giving you all the auto tests to test every possible condition. In the first few questions, the auto tests are a lot more extensive. As you move through the exam, we really cut down the hand holding, and you need to do your own testing as well, okay? So think of those boundary conditions and those weird situations where, you know, you might run into some issues. Okay. Oh yes, very important. Okay, there are no marks given to style. Okay, you can really let yourself go. If you let yourself go too much though, and I cannot read what you have written because there is no white space, no indentation, I will not give it marks because I will not know what on earth you're trying to say. There are many, many of you in this course. This course has over 1,000 students. I cannot spend you know, hours deciphering what one student has written if they've got very, very bad style. So whilst I don't care if you leave one space here or one space there, that's not marked. Please give white space, separate, and have clear denunciation of sections of code, because it makes it a lot easier to see where you might have made a mistake as well. So there are a few people marking these exams, so please be kind to them as well, because it's not the most fun job, as I'm sure sitting the exam is also not the most fun job. Okay, so when you get all your exam stuff in the beginning, it will also move across any starter files that there might be for the practical questions. You'll have that 10 minutes as well to read things, so you'll actually have an idea of what the questions are. You might get an idea of which questions you'll go for first, which ones you'll answer first. So that will be good. So start with the easier questions. You know, really try and move in order. It just because you want to be able to pass the hurdles as well before you kind of start getting to the rest of the exam to actually gain more marks. I have seen an exam where someone has answered a question 5 and 6 and then forgot to do the hurdles. Please don't do that, because it breaks my heart to fail you, even because clearly you know what you're doing, but you have not met the hurdles of this exam. So please do not do that. Okay, someone I can just see on the chat, when do you get the form to choose the sessions? It will be on Monday next week. You'll get an email and it will allow you to preference which session you want for this exam. Okay, what else? Yep, okay, prepare before you answer each question. You know, sit down, work out what you're going to do. You'll be given a little piece of paper each that you can squiggle on. You can ask for more pages if you want, of like rough working out paper. You can use many pages if you want. So, you know, draw some diagrams, do whatever you need to do, and then you can kind of go from there. Oh, someone on the chat's asking, what's the fail rate? That is a very good question. I cannot give you a straight answer because that fail rate has changed very much over the terms when the exam was online to when the exam moved to be in person. Yep. I think I will not answer that. But actually, I will say this. I have seen, for the most part, the majority of people will pass the hurdles easily. Okay? The people that do not pass the hurdles usually have not attempted the exam, so it makes sense. They haven't attempted a single question, they're not going to pass the hurdles. Most people, to make you feel better, will be able to get through the first 2 hurdles. They're not, and we'll go look at, you know, questions, and you can have a look, you know, as well what it looks like. Okay, in the lead up to the exam, you will, actually, you know what, I will give you some stats, because I know that people are very nervous about the exam. I've seen the chatter. So, let's say last term, and I'm going to give it very broadly, okay? There was quite a few fails. However, half of those fails were something called absent fails, okay? And what that means is that the student has not attempted the course at all, okay? Some people enroll and they don't do anything in the course. So some of the other fails were people that might have struggled throughout, or people that had problems and throughout the course. Now, just remember, please, it is just one course, and failing a course does not mean that you are not smart enough to be here or you're not smart enough to do computing. Lots of our tutors have failed a course. I have failed courses. It doesn't mean that. Sometimes you just don't have enough time in your day to do all the studying that needs to be done. Sometimes you're transitioning, you have you've come out of high school, you are now at university, you might have a job that's taking up a lot of your time, you might be paying rent, you might have moved out of home for the first time. So please give yourself some grace as well. It's not, I reckon this is the hardest course just because it's the first time you're kind of doing something like this. I always felt like when I failed at uni, for me, it was just a big financial hit. That was a point for later, Sasha, because it's on HEX. Probably not the best life advice, but you know what? You're still, it's just a course, right? I know it doesn't feel very nice when you're not doing great, but it's just a course. And just do the best that you can. Okay. Yes, less questions answered completely is better than more questions answered incompletely, okay? So it is good to be able to answer less questions but do them properly and answer them properly than to partially answer, all 11 questions and get 1 mark in each question. Okay, first part, the questions 5 and 6, they are 1 dot. Those are the questions that I have seen almost everyone does them, okay? Almost everyone completes them. So hopefully that will be the case again. They are going to be similar to your practical test. Someone's saying drop out. Do not drop out if you fail 1 course. That is not how life at uni is. Absolutely not. You know what? It should be based on enjoyment. If you are not enjoying computing, then you should consider perhaps something else. But, if you're still enjoying it, just don't worry about debt. You're like 18. You've got plenty of time to pay off debt. All right. Question 5 and 6. Do they have starter code? They just have, yes, they have not starter code, but it will have you write a function. And then we have our own main that runs your function. So we're testing your function per se. Question 5 is an array question. Question 6 is a linked list hurdle. So basically these are simple questions. They will test your ability to use variables, to use a simple array, perhaps simple struct, if statements, while loops, that shouldn't say question 1, that should say question 5. And question 6 is like basic linked list. So what that means is that question 6 might have you traversing a list and doing something in that list, but nothing more than that. Okay, so for example, a question 5, loop through an array of structs and gather some kind of information. So you'll be given an array of structs and you'll be told, print out the total of the number of steps taken in a specific direction. So for example, if the direction is L, which is stored inside your char, then you will find all the structs with that and then you will add up the numbers in those structs up. And we'll do those types of questions as well just to show you what's going on. But it's just an example. Example of question 6, so like a linked list one. Given a linked list, print the largest value in that list. And all you are doing, okay, is writing the function that pulses through a linked list and finds that largest number in a linked list, okay? So what that means is that you don't have to write something that reads in the linked list. We do all of that for you. You just have to write the function. Someone has got very weird ideas about HEX. You know that HEX is not paid if you go overseas to work as well, so strongly recommend. That's why so many people go overseas. Okay. Hey? Okay, so the next two questions, 7 and 8, they are 2-dot questions. See how we're building up the difficulty? They will be similar to your practice exam as well, to your practical questions 7 and 8 as well. Now, if you've answered 5 and 6, that means you've already passed the hurdles of the exam and you're now just here for, I would like to say fun, but mostly for marks now. So you are now here for marks and to get as many marks as possible. These two questions are harder applications of the hurdles. That means that in question 5, you might be doing something more difficult with an array, and in question 6, you're going to be doing something more difficult with a linked list. So perhaps you might insert or remove something because those are the harder things you can do. You might loop through more than once. Yep.
Wait, sorry, did you mean question 5 and 6 or do you mean 7 and 8?
This is 7 and 8. 7 and 8 are harder applications of 5 and 6. So like similar questions, arrays and linked lists, but they are harder applications. So you might be looping more than once through an array, doing something more than once in there, and you might be inserting or deleting from a linked list in these types of questions. Okay, then we get to 9 and 10. 9 and 10 are 3-dot difficulty. Okay, so 9 and 10 is harder manipulation of arrays, potentially. Might be a string question. That means you might be using fgets or doing some sort of string manipulation. And then question 10 may be like a much harder linked list question, which, you know, you add, you remove, you manipulate, you potentially use malloc, you use free, you use structs, you use pointers. So like the world's your oyster, right? It's a 3-dot question, and that's what it looks like. So basically more complex combinations, and then some interesting problem solving, which is probably something you do not want to be doing in an exam, but maybe some of you do, and that's what you'll be doing. And finally, question 11. Did you attempt question 11? The last question in the exam? I feel like you did. Yes.
I got partial marks.
Yeah, there we go. So it is possible to get partial marks. Tom, did you attempt the last?
Absolutely not.
Absolutely not. Okay, and Tom is now a tutor. Sophia, did you attempt the last question in the exam?
I wrote a love letter to Sasha.
You
instead.
did write a love letter to me, which I appreciated very much. So do not worry if you get to this question, you read it and you go, what the hell? You do not have to attempt it if you don't want to. It's all good. This question is for those really aiming for a high HD almost. And it basically, everything that's taught in this course might be in these questions. Basically, anything that's a mixture of the 3 dots and the skull challenges as well. We will have one example of such a question in the practice exam. So you've got, you can see what the difficulty is like and whether you think you'll be able to attempt it. And partial completion will get you some marks. Okay, what should you study? I guess everything. It's always such, I don't know why I put this slide in. Everything. The basics are important though. You should know how to use arrays and you should know how to use linked lists. If you have been able to do, stage 1, stage 2 of assignment 1, stage 1, stage 2 of assignment 2, you are well prepared for the first sort of 8 questions in the exam, okay? And that means that you've played around a lot with these, types of data structures and you should be able to do the exam, okay? We have revision exercises on our course webpage. They will be very useful to go through, but also one of the more useful things to do is to go through your problem sets again and try and do the questions again now with everything that you know and all the knowledge that you've built up as well. Okay, marking. Most of the marking is automated, but not we still look at all of the questions manually, those that haven't gotten full marks really. So make sure that your input-output is going to match the specification. A lot of the time, we print out the output for you. We just get you to do the function and return something from it so that you do not run into this problem where you fail the auto tests and get 0 and then it's really just you forgetting a space or a new line. So so we'll check the hurdles by hand and we also check the other questions by hand as well to make sure that you are given the most possible marks. Remember that marks are earned for correct code, not for passing auto tests. What that means is we might test other things in our auto marking that were not in the auto tests, okay? And if you have a minor error, like a typo or something like that in an otherwise correct solution, well, maybe a small loss of marks or sometimes no loss of marks at all. If I can see you've done everything exactly correct, you'll get full marks for that question. But please just match things, okay? It saves so much time if you just match the output. Okay, so again, while some parts of the exam are going to be very challenging, especially the later questions in the exam, you don't need to complete them to get a good mark in the course overall, okay? Remember that you're at university now, and you know, for 65 to 75 is a credit, you know, 75 to 85 is a distinction. You're not in high school anymore, you know, getting distinctions is like amazing marks, getting credits is amazing marks. And my father always taught me, P's get degrees, anything more than a P, you've worked too hard and you should be down at the pub having a drink. So please, please, please make sure you breathe, make sure that you just, it's a course and it's just one course in what is a long degree. So make sure to study, but then, you know, do the best that you can do. Okay, when you are struggling to understand anything, draw a diagram, especially with linked lists, okay? Please make sure to draw diagrams. Go over the problem sets and the revision questions. I see lots of people, okay, you know what? I was not born in Australia. I am a child of immigrants and I was born elsewhere and I came here as a refugee. My parents also did not think that low marks are that good, except when you're at university because you've made it. And you know what? You're old enough now to do what you want to do. I just stopped telling my parents what I was getting and moved out of home. So, you know what? You've got this. You've got this, I promise. Do this for yourself, not for your parents, and you will do something that you actually, you know, enjoy. That's why they brought you here, and that's why you're here studying, to have a better life. In reality, they all just want you to be happy. Okay, and then revision classes are coming. All right, let's take a break after that inspiring talk. Hey? That is a lie. We're not sitting 4 exams, just 1 exam. It does, because that's why maths didn't do it, but yeah. back. All right, let's come back. Let's do some fun stuff. Enough about the exam. Let's do some fun stuff. Okay, fun stuff today, multi-file projects. Okay, what are multi-file projects? They are things that you can do to make your code even more readable and even better structured, and so that multiple people can work across one project. What that means is that so far, I guess, your programs have not been that big, so this seems very abstract. But when you're working on bigger programs that span, thousands of lines of code and so on and so forth, you often work across multiple files. So not only does it improve readability and reduces the length of the program so that there is not thousands and thousands and thousands of lines to scroll through, but you can also separate the code by subject matter. So you can have, let's say, in assignment 1 you had, moving, spawning enemies, and that could have been one thing, one file. Then you could have had another module that had, flooding or whatever else. So that means, not for you obviously, you had to work on your own, but out in the real world, often there are multiple people working on one project. And what that means is that one person could have been working on flooding, another person could have been working on spawning, and so on and so forward. So really, you have already been using multi-file projects, really, because you have been hash including certain standard libraries. So what you're doing there is you are using someone else's code and just adding it in, tucking it into your code as well. But so far, we've only been including standard C libraries. We haven't been including anything that we have written ourselves. So now is the time to shine, and now is the time that we get to hash include our own library. What fun. This allows us to join projects together, allows multiple people to work on things, although I do not recommend that in this course you work together like that. That is called plagiarism. Please do not do it. And actually on that, if anyone is struggling with assignment 2 and you feel the burning desire to plagiarize, please do not. Please get in touch with us. We can help you. Please, 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 please do not plagiarize. Okay. Now, back to this. Sorry, that was a tangent that I shouldn't have gone on. Okay, so what that means also is that I can produce code in a module that I can then use in a different project. So for example, my linked list stuff that we've been writing, things like creating a node, things like deleting a node, they are not creative functions. They are standard things that might be used across multiple uses and multiple programs. What that means is once I have that module, I can plug it in anywhere I want, and that means I get to be lazy and not have to copy code. Okay, so how does this whole multi-file idea work? Yeah?
Are we allowed to do that in the exam? Like, if we know there's going to be several questions including linked lists, are we allowed to just make a library for managing linked lists and then use those in our...
I would not recommend doing that in the exam because we pull out, we pull out the function that you wrote to test it. So you can only, yeah, so you can only, exactly.
But not outside.
That's right. That's right. So, yeah. Okay. So, okay, there's a question again. Are multi-file projects assessed in our exam? Whilst they're not directly assessed in the exam, you might benefit from knowing what they are later on, and you will benefit from knowing what they are in the next, in the next few courses that you do in computing as well. Okay, so in our multi-file project, what we have is we have a header file, okay? That's your .h file. When you include your own header file, you do it, so usually we've been doing it in greater than, less than symbols, but when it's your own, it's in double quotation marks. Okay, so that means, we'll talk about it in a second. Okay, so you've got a header file, and then you will have an implementation file. This is a .c file, and in this file, you will implement whatever on earth you have defined inside your header file. So each header file that you have will have its own implementation file. And that means that perhaps you have your function prototypes, your definitions in the header file, and then you will actually write those functions inside the implementation.c file. And then the final thing that you'll have is you'll have your main.c file. Okay? The main.c, that's the entry into the program, and we try to have as little code there as possible. So what you're trying to achieve is basically inside your main, you're just going to be calling a whole bunch of functions. You're not really going to be performing anything logical or doing any code in there as much as possible. Okay, so the header file, that first file, and we'll practice writing one of these. Okay, the header file, you will hash include it with double quotation marks, and it will have a .h extension, H for header. And what it will have inside it is your function prototypes for the functions that will be implemented in the implementation file. You will also have your comments that explain what those functions are doing and how they're used. Yep.
So when you say something .h, right? Is .h part of the file name, or is .h like the file type?
It's the extension, so it's like the header file. So let's say linked list.c was my file, and I want to make that into a multi-file, which I will do later. What I'll have is I'll have a main.c, then I'll define my function inside linked list.h, and I'm calling it linked list.h because that feels like a good name for it. And then I'll implement the functions I've defined inside linked list.c, and I'll call those functions inside main.c.
Why don't we just do hash include linked list.c? Is that just how?
So you don't include the .c files, you only include the .h files, and we'll talk about that in a second. Okay, so basically any hash defines will go in your header file as well. And this is the file that will show the programmer all that they need to know, to use the code. So there's no running code inside a header file. It's really your definitions. Okay, it's the definition file. Yeah.
Do you also put your struct, your very first struct thing?
What a wonderful question. Okay, you could. Okay, but what that means is if you've done that, anyone else using that header file is stuck to your definition of what a struct is. So it depends how a project is structured. If you want to lock in a definition of a struct, or if you want people to be able to define it differently when they're writing their functions.
You also do typeless.
Yes. But not in 1511. Hey? No, with Sasha. I cut them from 1511. And the reason I cut them is because they hide in the beginning, they hide something that's important for a novice to understand. Okay, then your implementation file. This is where you implement whatever you've defined inside your header file. Okay, so this is where you actually write the functions that you've given the prototypes for inside the header. And then your main.c, and that's where you call the functions from that hopefully exist in other modules. Okay, I think, should we write one of these and see how it works? Yeah, let's do it. Let's do a simple one as well. I decided to do a maths one because I think we can do that really quickly. And then we can perhaps break down our linked list big long file, which has become quite unruly from last week. We can break that up into a multi-file as well. That's the wrong mouse. Okay, so the first thing I'll do is I'll do my header file because I'll define what it is that I want to actually do and implement. So any hash defines will go in here, and also any function prototypes. So if I'm creating this little maths module, I don't know, what are some simple things that you can think of that we can implement for maths?
Absolute value.
Absolute value, okay, we could do that. So we could do... Okay. second. Okay, so let's do one absolute value. It's a nice one. No one's ever wanted to do that one. Okay, anything else? Yeah. Why are we choosing such... I really want someone to choose something that might need a hash define for me, just to show you that a hash define can go in here as well.
Radius of the
Let's do area of a circle, or something to do with pi. Let's do a hash define for pi. That's not... Okay, hash define, and let's do pi. Okay, so let's do function. Area of a circle. Okay, should we do any more? Should just we leave it at 2 to start with? Everyone is so just fading. Week 9 fades. We can do one more. Let's do it like a fast one, function that sums up things. Sums up 2 numbers. There you go. That's a fast and an easy one. All right, so in here we're going to have the definition, so the prototypes. So what would be the input and the output of a function to calculate an absolute value of a number? What would be the input of this function? Number, yeah? What will be the output of this function? Yep. Excellent. Okay, great. So let's call it absolute value, and then we're going to give it an int as well. Okay, what about a function that calculates area of a circle? What would be the input and what would be the output for it? Radius, yeah. So that means we're going to have to, oh, well, we might not necessarily give it an int. Radius doesn't have to be an int. Might be a double, might be a, yeah. And what will be the output? Yeah, so the area, which is potentially also going to be a double because pi is also a double, yeah? Okay, great. What else have we got? Okay, so that means we're going to output a double. It's going to be, I forgot what we're doing, area, circle. And we're going to give it a double, and we're going to give it a radius. Okay, and function that sums up 2 numbers. What do we reckon will be the input and the output for it? Input for a function that sums up 2 numbers? 2 numbers, yes, exactly. Very good. So we're going to give it 2 ints. Okay, so I'm going to give it 2 ints. And what will be the output of it? 1 number, yes, 1 int. Well done. So output is int. It's going to be sum, and we're going to give it int number 1 and int number 2. Excellent. Okay. So now in my header file, what I have is I have 3 functions defined and I've got a pi defined. So I've got absolute value, circle, area, and sum. Okay, great. So now I'm going to go across to my .c file and I'm going to implement those things. Okay, so to implement those things, I'm going to go inside my .c file. And what I'm going to do inside this .c file is I'm going to hash include my maths.h. So what that will do is it will quickly grab whatever is sitting inside here and basically place it, you know, at the top of this file. So all those function prototypes are available to my .c file. So you only ever include a .h file because it defines everything for you. Okay, so I've got my maths.h included, so now I am ready to start actually writing the functions. Yeah. Okay, so normally when we do our hash include, let's just spell that correctly. Normally, oh my God. Okay, there we go. We'll do something like that, yeah? So that's for standard library when you have these types of greater than, less than. This just means that it's my own library that I'm going to refer it to, okay? And it's going to be like in the same folder altogether. Okay, so implementation, I've included my maths.h, so let's implement these files, these functions, not these files. Okay, let's do absolute value first. Okay, what will I do here? How will I calculate absolute value? Thoughts, ideas, suggestions? Yeah. Beautiful. So if the number is negative, is it nice to be doing such simple things after you've been doing linked lists? Does this make you feel alive again? So if the number is negative, multiply it by -1. Okay, so we're going to check if that number that was given is going to be less than 0. Then I'm going to multiply it by -1. Yeah? So I'm going to return my spelling is really going downhill. Otherwise, I'm just going to return the number. Okay, absolute value. Let's do our circle. Okay, so circle, we've got double area circle, I think it was called, I hope so. And we've got a double radius. Okay, so let's calculate an area. Double area is equal to, okay, so now inside my maths.h, I've also defined pi to be 3.14, and area of a circle is pi r squared. It is, isn't it? Yeah. Okay, so it's going to be pi times radius times radius. We could write another function to do a square of a number as well, but so I could do that, and then I could return area, or I could also just return that whole expression if I wanted to. Okay, great. And then we've got the easy one to finish off with in sum, and it's given two numbers. And then this function is just really going to return number 1 plus number 2. Okay, so now we have defined functions, and we have also implemented all of those functions as well. Okay, so now that we've defined and implemented them, it's time to go to our main.c, and then we can see what's going on there. So inside the main.c, which is the file where you're going to call everything from, where you're going to call all the functions from and use them, what you will include any of your standard things, because you're using printf or scanf, for example. And you will also include the header file for everything that you've written and have prototype, because what that will do is that will allow you access to all of those functions that you have written as well. So it's always the .h files that get included. Okay, great. So now we have an int main, and now we want to be able to start, actually calling our functions. Okay, I'm going to declare double radius, because then I'm going to have, I'm going to scan in some input from the user for a radius. So I'll use a scanf and place it inside radius, and now I can start calling functions as well. Okay, so what should we call? Let's do, so I'll do first of all the area of circle with radius. LF is %LF. Okay, so that's the first one. So in the first one, I've got the radius, so I'm going to ask it for whatever's inside radius. And the second one, I want to be calling my function. So my area circle, and whatever it will return will go into that placeholder. And I'm going to give it the radius to calculate with. Okay, so that's the first one. And then I might have an absolute value, so I'll make a call out for that. So the absolute value of -3 is %d, and then what I'll do is I'll call my absolute function. Is that what it was called? No, it was called absolute value. So I'll call my absolute value function, and I'll give it -3. This is obviously hard-coded, but it gives you the idea of me calling these functions. And then perhaps I'll do one where I sum up some things. So the sum of 3 and 5 is something. And then I will call my sum function and I'll give it 3 and 5. Okay, great, excellent. So now we've got a main and now we've got, we've got all of our files here going on. So now all that's left to do is we have to compile. Okay, great. How do you think you would compile a multi-file program? Because I now have multiple C files and I have a H file. What do you think I will compile? What do you reckon? Just take a guess. They're relaxing, it's week 9. Main.c, I will definitely compile my main.c, okay? What else would I compile?
Math.c.
I will compile maths.c as well. Do you reckon I'll compile a maths.h? No, I will not, okay? Because I have included maths.h in all of my C files, what that means is it will take whatever is sitting inside that maths.h and it will place it on top of my C file when it compiles, so it's available to it. So when I compile, I will compile the .c files, and let's say I'm going to make a program called maths. And that is happening because I'm in the wrong directory. So let me just quickly go back to where we were, where all my files are. Here we go. Let's try that again now. Okay, so I'll compile. Everything is great. And now I will run it in the same way as I normally run things. I will not be able to do this calculation, but I'm going to assume it's all correct. So the area of the circle is blah, the absolute value of -3 is 3, and the sum of 3 plus 5 is 8. So look at us go. We can do magical things now in a multi-file situation. Yeah?
So you said when you do hash include, it just that puts the contents of that file.
It's a very simplistic explanation of what is happening. But basically, it'll take that chunk and it will like add it itself to the beginning of, it'll make a huge, like long thing basically.
Okay. So if that's the case, how come we can't just hash include math.c in our main?
So you can't include an implementation file. You can only include a definition file. The functions are stored elsewhere, and what happens is, because I'm including the .h file, okay, but I compile the implementation file, and that implementation file includes the header file that has all the definitions. So in my main.c, so if you notice, I compile all my .c's. If I didn't compile, so if I compiled it without doing the implementation file, so if I do it like that, it will kind of go crazy because now I'm using all of these functions that it doesn't know about, they're not implemented anywhere, right? So you include the .h's, you compile the .c's, and this is just a really simple kind of include .h's, compile .c's, have a good life. And because you can have multiple, right, multiple implementations as well. So for example, I could have, I'd like to say a stack, but you don't know what a stack is. Anyway, so a stack can be a stack is another structure that is basically, think like you're stacking up dishes. But I can implement it with arrays, which is crazy, but I could. And I can implement it with linked lists as well, okay? So what it means is my header file doesn't care really how I implement it. I could have both ways. Someone could go off, 2 different people. To someone it makes sense to do it with arrays, to someone else it makes sense to do it. So you're not really locking them into like, you're letting people do their own implementations basically.
So you can achieve the same thing.
I can do many things in many different ways in computing. So it allows me to shine. Okay, how's everyone feeling about that? Tom, could you just do a little poll? I know everyone is waning. It's all happening. We're going to do the same thing to a linked list now. We're going to break it all up into a multi-file. How's everyone in the lecture theatre feeling? Yay! Just one thumbs up across the whole theatre. Things are going great. Always can rely on you, Ben. Yeah. Okay, so think about it like this, okay? When you've been including the standard libraries, okay, and you're including the header file for the standard library, are you including every single, like are you including the implementation file for it? No, you're including the header because that's what defines all of those, because then you can compile, for example, I want to run it, and the stack example, I want to test an array implementation. I can have that header file, it doesn't, but I compile my array implementation file and I'm checking it with that.
Oh, I see. So the header file doesn't know where it's going to be called, or like how it's going to be called.
Well, it does, I can have multiple implementations of the same, of the same thing.
That's why you only call the header file without the you have more than one way of using the header file in different.
Yeah, and that's why I compile the .cs. So it's like, you know, you could pit people up against each other. I can be like, okay, Sophia, Ben, Tom, here's a header file. I would like each of you to implement these functions, and then I'm going to test the complexity and see whose is the most efficient. And that's what we're going to use in our program code in the end. Tom's out. Okay. There was a poll running. People are feeling the squeeze. Oh, not bad, not bad. Okay. Okay. We should do a poll. How's everyone feeling about their first term? Okay, excellent. There have been some questions. I know Tom and everyone's been answering them. Okay, good. Shall we do it to linked list? Let's do it to the linked list file because that's messy. Okay, so the linked list one is inside C, inside week 8. That did not make sense what I just said. Inside our. So what I'm going to do is I'm going to go to week 8. And then I'm going to, I don't know, why not? I'm going to get a folder and I'm going to call it linked list. And then you know what I'll do? I'll give you all access to it so you can see what on earth is going on. Okay, then I'll go inside. Okay, so now I'm going to have my 3 files, okay? So I'll make 3 files. So I'll have a H file, I'll have an implementation file, and I'll have a main file. Okay, so let's have a look. Okay, so this is going to get a bit confusing, but we're gonna go with it. Okay, let's go inside our header. Oh my God! Also, I've made a spelling mistake as per usual, so that's going to be good. Okay, so let's do it. Let's move things along. Okay, inside my H, let me see what we have in here. We have all of these functions. So I'm going to move this across because these are going to be now inside my .h file. Okay, so first of all I'm going to define what it is, and then we're going to copy the functions across. So this is my header file where I will define all the functions I am going to to use with my linked lists. Okay, and then the functions are, okay, and then in here is where you would also make your comments. So this function prints out a linked list. This function creates a new node. This function gets the size of a linked list. This messy function, I remember it, it was very messy. Inserts in the middle of a linked list. And then this function deletes a node. Okay, so we've got our .h file. Now we go and we move across to our implementation file. And inside the implementation file is where we're actually going to write all of these functions, okay? So let's go across and we're going to literally copy the functions across. So in here, I'm just going to copy this across. Okay, so I've got delete node, got the insert middle. Okay, so in my implementation file that I am in right now, what I must do is I must include my .h file, so my header file that is going to link everything together. So linked list.h is now going to be included. Okay, what else will I need to do here? So in this particular thing, in this particular file implementation, I'm using commands like free, and I'm pretty sure I'm using malloc in here as well. So because I'm using all of those, I'm also going to include my standard library, otherwise I will have no access to those. So standard library will get included as well. And am I doing any printing or scanning in here? I am, I'm printing something out. So shouldn't really be happening inside an implementation file or whatever, okay? So I'm gonna just do my standard input-output as well. Okay, great. And then we're going to go across to our main.c, and that's where we're going to copy, we're going to call and run things from. Okay, and that's another good question there. We're going to do that in a second. Okay, so right now I've got my main, and inside this main I no longer need the function prototypes. So right now I am defining my struct inside the main. Okay, do you think this is a good place to define a struct node? Yeah, okay. Let's have a shower of hands who thinks it's a good idea to define it in main. Yeah, a few people. Where else could I define it? I could define it in the other .c file, in my implementation file.
But that locks you in, right?
It doesn't, doing it in the .h file locks everyone into a certain definition. But implementation is all me, right? It's all my crazy. It's whatever I want it to be. So what I can do is I can move this out and put it inside my implementation file, because my implementation here, all of my functions, the way I call them and the way I use them, is based on this definition of a node, okay? So maybe someone else will choose to do it differently. Their implementation might have a different definition of a node. It doesn't matter, because they'll still be able to return the same things that I need them to return. So I've moved that out, and now inside here is really just going to be my main file where I'm calling all of my commands from. Okay, So first thing I need to do, I am using printf in here, I think. Yep, so I'm going to hash include my stdio.h, and then what I'm going to do is I'm going to hash include my own library as well, so that I have access to all of those wonderful things that I have written, all the functions. Okay, so now that's all separated. Let's see if we can compile it. So to compile, I will compile my main.c and also my linked list.c. Okay, and then just madhouse. Oh, quite a few madhouses here. Just wait for it. Nope, still going. Here we go. What fun. What fun. This is what happens when you don't just do things from scratch. This is what happens when you copy and paste. Hey? No, not yet. No, not yet. This is why I never copy and paste things. I've done something here that's calling, yeah. I'm not going to rewrite this code, so what I'm going to do is I'm going to move this back. Okay. Hey? If I put it in .h, it's available everywhere, but I have just gone on a big rant to not do that, so I'm not going to do that. Okay, the code is written in such a way right now that is not considering a multi-file application, which is why I'm using a node somehow in my main instead of just using functions and function calls. So I'm going to have to go back on what I've said here, and because of the way I've programmed it, which is not, because it's just a copy and paste job right now, I'm going to move that in out of here and in there. Okay, let's try that again. Did I save it?
I think it,
Did I run it before I saved it?
I think it has to go with .h.
Where have I defined it? Wait. Oh. Don't ever do this. Please don't do this. I've just forced everyone into this implementation. I shouldn't have done this. We should rewrite all of these functions.
Not safe.
Thank you. Okay, if we run it again, it's going to print out whatever on earth we had it doing here, which is just creating nodes, running nodes, printing size of the linked list, and so on and so forth. Okay, so that was all happening because the way the main is written, it's not just calling functions, it's also got some logic inside it, which is just, this is just horrific stuff. Okay, don't ever do that if you're doing multi-files. Okay, so, you know what I'm going to do? I bet everyone is super excited about what I'm going to do. I'm going to get you to do the poll right now so that we can prepare for next week. And maybe we've got a little bit of time. Maybe we can do something off the cuff, because that's the way I love to do things. Watch things burn. Right, come on, put your votes in. What are we going to do next week? And maybe right now. I've reached new levels. Yeah. Hey? Andrew better not see me do this and be like, why do you need Kahoot? me some music quickly. Oh no, Sophia's going to play us some Taylor Swift, I bet. Oh no, she's just going to play us some group music.
Taylor Swift is copyrighted. I can't play that. Yeah, I don't want the collector to take it down.
Why is the most chosen one not being shown? Because when something goes on.
Oh, there we go. Yeah, it's hiding the top one just because of the way it's
Building suspense.
yeah.
There we go.
Is this a new computer?
Yeah, new speakers. First time I'm using them.
Whoa! Just boombox on the side. I think pointers are above the linked lists and they're just being voted up.
Yeah,
1%. We can't loop inside linked lists or arrays if we do them. I'm going to get a headache from this.
For 10 hours?
Oh, 10 hours. Wow, thanks.
Your favorite? I think that's enough for music.
All right, any more voting happening? Nope. Okay, a bit more happening, but really it's just pointers for the win and then linked lists and then strings. I don't know why I bother taking the poll. It's literally the same every single term. I swear it is. It's always pointers, strings, and linked lists. Okay, excellent. Oh, pointers have gone down. Okay, now what I'm going to do, Tom, I'm going to get you to do another poll so that I'm not just making up linked list functions for funsies. I would like for you to check if we want to go over inserting, deleting, or like traversing, manipulating a linked list. So what is the choice out of those three? Do we want to do? And for those of you that are in the theatre, I don't know how to vote. There's three choices. And even if I said left or right arm, that could be not that good. Don't hit anyone next to you.
Did not like, everyone stand up and decide your choice.
That would work great on my computer.
That's too much for a Thursday afternoon, 1:43. Why does it keep collapsing so I can't see? For those of you, just vote on YouTube as well. Just in deleting. People really don't like deleting. I thought that was so good, the deletion. Okay, this is good. Traversing. No one wants to insert. Okay. A print we've already written a print function.
But it's Tom's favorite.
Yeah, okay. Tom just wants to go write a print function for linked lists, so he's really keeping it real. Hey?
Oh yeah.
Wow, yeah. Okay, well let's do a traverse, because a delete will take me too long now, and I'll prepare some questions that will delete a list. Let me make up a question quickly. What question should I make up? Throw me a question that will involve traversing and looking for something in a linked list.
Find a value.
They're creative.
Did you just say find all the values in a linked list? So you're just telling me to print a list. Okay, let's do that. Let's print out all the even values. He's got to do the printing, so let's give Tom his printing. Let's print out all values in a linked list. So let's do a function to print out all the values in a linked list that are divisible by 2, so that are even. Should we do that? Yep. Okay, so let's call the function print even. And what will we give that function? What will be the input? Someone say head? Anyone? Head? Yeah. What will be the output of the function?
The number that I use.
Yep, but is it going to return anything to our main?
It looks like it's just printed.
Yeah, it's just printing, void, okay? So we're going to have a function, it's going to print even, we're going to give it the head of the list, and then we're going to traverse it and find the printing of the even things. Amazing. Okay, so now let's go inside our linked list.h, and that's where I'm going to define, so this function will print out all the even numbers inside a linked list. Okay, and we said that it's going to be a void because it's printing. It's called print even, and we are giving it a head. Okay, excellent. So now that we've defined it in our header file, what we want to do is we want to go to our .c file, implementation file, and we're actually going to implement this function. Okay, so now let's say we've got this horrible linked list. Where is this linked list? It's huge, isn't it? 1, 18, 11. Okay, so the linked list looks something like this. 1, 18, 11, 7, 5, 9. What I wanted to print out for me, what an odd linked list. It's only got one even number. So I wanted to come back and print out 18. This is currently the head, and I want to move through this linked list every time checking if that number is divisible by 2 or not. Okay? And this is kind of like reminiscent of, question 6. So like the first, you might have to traverse a linked list and you will have to find something inside that linked list. Usually only one traversal. Okay. So, first thing I do is I'm going to get myself a current node that I'm going to keep track of where I am in the list, and I'm going to set it to the head of the list. And that means that over here, where I'm the head, I'm also now the current. Okay? Then I'm going to need to traverse through the list. So, I'm going to move through my list. And I usually do that with a loop. So, I'm going to have a while loop that will move me through my linked list. And what will be my condition inside the loop? Will I be going through the whole list, and will I be moving until I get to the end of the list? So do I want to stop when I'm at null, or do I want to stop when I'm at the last node? Yeah. Null, yeah. I want to move through the whole list so that I get a chance to check every single item in the list. And if I check every single item in the list, then I'm going to go until current is not equal to null, because what that means is that when I come out of this while loop, so outside of this while loop over here, my current is going to be equal to null, and that's going to break me out of that loop. See, for that 1% that wanted to do looping, we're doing loops too. Okay, so whilst current is not equal to null, I'm going to move in the list. So to move across, I'm going to say current, next. What that will do is that will assign the address sitting inside my next point of a node into my current. So whatever is sitting in there, it will assign it to my current, and that means I will move my current one across each time. Okay, great. So now all that's left to do, so now I'm able to loop through the list, and I'm also able to move along that list and kind of, but what I need to be able to do now is I need to check whether or not, that element is divisible by 2, whether it's even. How will I do that? Yep.
If current minus current on 2 equals current on 2.
If, sorry, say it again.
So if like current data
Yeah.
like on 2
Yeah.
equals current data minus current data on
Yeah. Okay, so if current data, so whatever is sitting inside that node, if modulus 2 is equal to 0, which means it's divisible by 0, then what I want to do is I want to print out that number. You know what, I'm just going to do that. Okay, fine. And new line here, and I'm going to exit out of here. Okay, great. And that's...
Then you have to say like current data, the printf statement?
Yes, I do. No, I'm just going to print out nothing. I'd like to see the compile, just checking if the compiler works. Okay, great. Okay, so now I've got a simple function here. What I'm going to do here, just to separate out all the output, is just say even numbers are. And then I'm going to call that function. Okay, let's save it. Let's compile it and see if it's working for us. Okay, and then let's run it. So, great. Even numbers are 18. Amazing. So that works. And that took us 4 minutes. Imagine how you can breeze through the exam. That is like a question that you can just 10 minutes, done. Okay, great. What else should we do? We've got time for another function at that rate. What other functions should we do? Quickly, on the spot. 5 minutes.
Delete value.
Dude, come on.
No, okay, never mind.
Simple. 5 minutes.
Insert the node at the tail of the list. Insert within the list.
No inserting or deleting. We're doing that next week.
Printing.
Simple.
Print.
Changing the value of the node.
What? Which? Okay.
Doubling the value of
Oh, exam ideas.
So how do you feel about that question?
Okay, changing the value of a node. Which one should we change? Oh my god, I don't want to do anything to do with the middle anymore.
Okay, that's the first value.
Let's do the first value.
double each value in the list.
Change the head. Change all of them. Yes, increase them all by 1.
Yeah.
What a question. What a question. Okay.
Bubble sort the list.
Hey.
Bubble sort the list.
We'll be here for more than 10 minutes.
First pass, second pass, third pass. Okay, so let's do a functions. Let's do a function that increments every item in the list by 2. We're on the 2 train now. Oh, someone's saying print the Fibonacci node in a linked list. Oh my god. Good questions though. Okay, print, no, not print, increment nodes. And let's see, in such a function where we would increment the nodes, what would be the input? What would be the input of this function? Head. Amazing. What would be the output of the function? Well, I'll have to return something. Yeah, I'll return a head. But I could do that as well. I could pass, yes. So, because we're not changing where the head is located, we're changing the value inside the head. So the head is really still the same head. So we might not necessarily need a return here. Okay, but we're going to give it the head to increment everything by... Oh, we should print it out as well, shouldn't we? And then I'll do printf. New list is... what was the function called that prints a list? Print list. Gosh, I'm good with variable names. Okay, print list head. Beautiful. Okay, now let's write this function. We've got 3 minutes. I can do it. And that was very high-pitched. I'm sorry in advance. Okay, increment, nodes, and we've given it a head Okay, excellent. And now what we're going to do, look at me starting the question all the time in the same way. I'm going to get a current node and I'm going to keep track of where I am in the list. And then I'm going to move through the list. Again, I'm going to go all the way to the end of the list because I want to access every single node, which means whilst current is not equal to null, what I'm going to do is I'm going to take and access the data in my current data. It's going to be equal to my current data plus 2. And then I'm going to move my current along. Let's see what happens now. Well, I've got it as a void, so I can't return it. Hey?
I was like, you might as well print between changing the dollar and
Okay, I forgot to put it in here as well. When multi-file projects are a pain. I forgot what I call the function. Nodes. The time pressure, it's like I'm doing the exam. Here we go, I'm doing the exam, here we go, it's running, it's run, and here we go, and the new list is, it was 1/18/11/75 now, and now it's 3, 20, 13, 9, 7, 11, whoever can do maths and increment by 2s, yay! Oh. And that's how I will feel every question you do in the exam. I'll be applauding you. So thank you everyone. I'll see you all next week for all of our revision. So that was the last bit of new stuff and now it's just revision. You've got this. One more week to go.